flag football clinic in Wichita. All right, so these are the 6-hour notes. Make sure you play along, and if you struggle bus during this, I'll email you the video when we're done.
Wait, Steven,
yes.
Did we get a packet yesterday?
We did indeed.
Dude, I'm telling you, it's like...
I believe that's the right one. Yeah. Okay. So the first 30 seconds of this video, boring. My bad, dog. So we're looking at rational exponents and simplifying, rewriting and simplifying rational exponents. So yesterday we took 25 raised to the 1/2 power. 2 is our index, 1 is our power, 25 is the base. Rewriting that as just the square root of 25, we get 5. And we did 32 raised to the 2/5 power. The index is 5, so we're looking at the 5th root of 32 squared. We can rewrite that with the 2 on the outside. The 5th root of 32 we find out is 2. 2 squared is 4. All right. So this process of rewriting, we're going to evaluate these 3. So rewrite and evaluate. We have 32 raised to the 3/5 power. Our index here is a 5, so we're looking at the 5th root of 32 cubed. Y'all have already done that in 5th hour. 6th hour hadn't gotten there yet. Since I don't want to go 32 cubed and then take the 5th root of that, I'm going to go smaller before I get bigger. So the 5th root of 32 all raised to the 3rd power. Now that we can handle. The 5th root of 32, everybody knows, is 2. And 2 cubed is 8. All right, looking at our next one, we have 27 raised to the negative 2/3 power. Oh, man. Yuck indeed. So the grossest part about this is the negative, right? So what happens when my exponent is negative? I send it to the bottom or the other side of a fraction, right? And then I make it a positive exponent. So 27 raised to the negative 2/3 becomes 1 over 27 raised to the positive 2/3. And now I can rewrite that from exponential to radical form, and I get 1 over. My index here is a 3, so we're looking at the cube root of 27, and then my power is a 2. Now again, I don't want to go 27 squared and then figure out the cube root of that, so I get 1 over the cube root of 27. All of that we're going to square. Does anybody know the cube root of 27? 3, yeah, so here we get 1 over 3 squared, which is 1/9. All right, really good. The last one here is 50 raised to the 3/4 power. And I can rewrite that. My index here is a 4, so we have the 4th root of 50 cubed. Again, I don't want to do 50 cubed, so let's take that as the 4th root of 50, and then we're going to cube that. So the 4th root of 50. Yeah, there's nothing friendly about the 4th root of 50. And so there's no way to do this by hand. So how do I use a calculator? Right, so here, I don't know what's going on with my calculator, but we have 50 raised to the 3/4 power, which is the 4th root of 50 raised to the 3rd power. Now, throwing that in a calculator, we have 50. I'm not going to do it with the radical. I'm going to use the calculator with fractional exponents, rational exponents. So the exponent button, x raised to the y, gives me an exponent, and I want 3/4. So 3 divided by 4 in my exponent. And now that gives us some nasty decimal, right? Rounding that to 2 decimal places, what do we have? 18.80. So all of this is equal to 18.80. So a couple of things. One, yes, I hate decimals, but if they ask us to find a value rounded to the nearest hundredth, that's going to be the decimal there. And that squiggly equal sign stands for approximately, meaning I'm rounding. It's not exact because I rounded. So this number is rounded. Anytime we leave a rounded number, it is proper to say approximately. So if I'm leaving a rounded answer, I'm going to say approximately. I'm not going to say exact. Question? Okay, sweet. No, you're good. All right, so on these problems here, application style problems, they're going to give you this nasty formula, right? So the fajita scale rating, F, of a tornado is represented by this nasty function that helps you choose whether or not you're going to have steak, chicken, or shrimp, or a combination of fajitas, right? And so what they tell us is W is the estimated wind speed of the tornado. That W right there, so if I have an estimated wind speed, I'm going to plug it into this formula, and it's going to tell me the size, the F rating of that tornado. Now, we live in Kansas, so we're used to seeing tornadoes. That's an F3 tornado. Or if you think about the Joplin, Missouri tornado, that was an F5. That was a big dog, right? But here, this tornado that took Dorothy and Toto had wind speeds of 100 miles an hour. So, since W is our estimated wind speed, W, the estimated wind speed, and W goes here in the formula, and they gave us a wind speed of 100 miles an hour, I'm going to take that 100 and plug it in for W. Oh, they did it for us. Great. And then they simplify, and simplify, and simplify, until they get 1.69. What that means is that a tornado with wind speeds of 100 miles an hour is classified as an F1 tornado according to the fajita scale, meaning you're only allowed to choose either chicken, steak, or shrimp. You're not allowed to have all three. Yeah, so be careful when you're looking at the fajita scale. El Pot better give me money for this. Anybody leaves this and goes to get El Pot, they owe me big time. These math notes are sponsored by. All right, so what's the value of each expression? Now, again, we want to rewrite these and then evaluate. So this 3/4 power. Butch, help me out, big dog. 3/4, the exponent. Is it attached to the 16, the -1, or the parentheses? Just the 16, right? So I have to evaluate what's inside the parentheses before I can handle that negative out front. So when I go to rewrite this, I'm going to write negative with a big old set of parentheses, and all I'm going to do now is evaluate 16 raised to the 3/4 power. So what is our index? 4, good. We were looking at the 4th root of the base 16, which is cubed. Now, I don't want to go 16 cubed, so I'm going to rewrite that, negative parentheses, as the 4th root of 16, and that is being cubed here. So, I've created a little bit of work for myself, but that's okay. The 4th root of 16, what's the principal 4th root of 16? 2. That's exactly right. So here now, on the inside, we have 2 cubed. Right, 4th root of 16 is 2. 2 cubed is on the inside of those parentheses. 2 cubed is 8, so here we have negative 8, which is nothing more than just negative 8. What do you bet, Butch, on part B? The 5th root of 3.5 to the 4th, is that something that we're going to be able to do by hand? No. But if I rewrite this in exponential form, I should be able to plug it in a calculator, no problem. So, Butch, help me out, big dog. What is the base here? 3.5, good. And what will the exponent be that I'm raising 3.5 to? 4/5, good job, dog. That's exactly right. So now that I can shove through the calculator hole. So I go 3.5, and then I put my exponent button up there. There it is. And I want to raise it to the 4/5. So 4 divided by 5 gives me that nice little fraction there. Enter, we get 2.7, is that 7.2 or 7.3? 7.2, yeah, good. So I'm going to use my approximate squiggles, 2.72. All right, again, round to the nearest hundredth if necessary. All right. Now, moving on. Simplify each expression. Assume all variables are positive. Now, I'm not going to make you do too much thinking here. When it tells us to assume all variables are positive, all that means is that I will not have any imaginary values. So if I have an even root, like 2, 4, 6, or 8, the root will still be okay because we're assuming that the variables are positive. All right, so on a problem like this, they did all the work for us, and look what they did. They said 32. Well, that's 2 to the 5th. And then they said 2 to the 5th and m to the 15th. Well, I can rewrite that as 2m cubed raised to the 5th. And now the 5th root of something to the 5th, those 5s cancel each other out, right? The 5th root of something to the 5th is going to cancel out, and we're left with 2m cubed. I personally don't like this because it requires a little bit too much thinking and writing. So what I like to do is separate this into two categories. Whenever I have to simplify an expression like this, I want to look at my numbers, and then I want to look at my variables. Because there's two separate questions that I'm asking myself when I simplify these things. All right, there's one question that'll help me simplify the numbers, like 32. There's another question I have to ask myself to simplify the variables. So, what we're going to do is we're going to use this fact. The fact is the square root of something times something else is equal to the square root of the first thing times the square root of the second thing. This fact allows us to separate the radical so I can handle it in parts. So when I'm looking at the 5th root of 32m to the 15th power, what I'm going to do is I'm going to write that as the 5th root of 32 times the 5th root of m to the 15th. And now when I do that, the question I need to ask myself, what number times itself 5 times is 32? Well, they already told us it's 2, but when I'm dealing with something like that, if I have to multiply a number by itself 5 times and it's only going to get me to 32, it's got to be a real small number. So 5th root of 32 is going to be 2. Now what's the 5th root of m to the 15th? M to the 3rd, right? 15 divided by 5 is 3. So here we get 2m to the 3rd. Yeah, I think it's a little bit easier than doing that. This seems a little bit more complicated. And now on this next problem, I don't even have any numbers. And to be fair, the only amount of work that I need to do is this division down here. I don't need to write it 4 different times just to do that division. 20 divided by 4, well, that's going to be x to the 5th. 8 divided by 4, that's going to be y squared. Right? So something like this, I think you should be able to hop straight to the answer without showing all of this extra. That is a lot of extra. All right. Roll it over. Last little part, we're going to do this 2 more times. Oh, no, not. I lied. We got 3 more slides. Bless you, I think. All right, so simplifying these expressions. Yeah, because I don't know, it's pretty high pitched for a sneeze. Yeah, no, Summer, nobody ever accused you of having a feminine sneeze.
Oh, sorry, please.
No, it's okay. Don't apologize. Dude, you're just being yourself. We love you for you. We don't expect you to have some sort of dainty sneeze. We leave that to the dainty girls.
I totally forgot what we were talking about. So.
Well, it's math. So here we go. Separate this out. We have the cube root of -8 times the cube root of a to the 3rd, b to the 9th. All right. So what do you think? What is the cube root of -8 going to give us? -2. Yeah, good. So you are allowed to have negatives underneath an odd root. Yeah, so that produces -2. What's the cube root of a to the 3rd? A to the 1st. Yep, good job. And the cube root of b to the 9th? B to the 3rd. And we're good to go. I don't even really need to do this step every single time. I can just think about the numbers differently than I think about the variables. So, can anybody tell me the fourth root of 256? 4. Really good job. Well, it can't be that big, right? And here's what I mean. 6 to the 4th, we're already at 12,000, and I can't get over 256. All right, so
what if it was 5 or 3?
Well, 5
Yeah.
5 is 25, 25, 25 is like, it's up there. And 3 times 3 times 3 times 3 is
Yeah, so 5 to the 4th gets us 625, so we know it has to be smaller.
Yeah, but it's like, you're just like things that are in their head.
Oh, somebody who's experienced this before, or, you just do some thinking. And 3 to the 4th is 81.
Yeah, but like, see, this isn't basically how we just think about it.
Hey, you haven't had to think about it yet, and now that you did, you've had that experience.
I don't know about that.
What's the fourth root of x to the 12th? X to the third. Good. And the fourth root of y to the 24th? I'll tell you. It's y to the 6th. I'm skinny, by the way, so.
That's a lot easier than what you're doing. It's just you divide the variable by the variable versus doing the variable all the way out like you're doing. It's a lot more complicated.
What, this is easy?
The variable is easy. It's the thing with the
The numbers?
It's that's hard.
Yeah, absolutely, fully agree. Handling the numbers is way more difficult than handling the variables. Fully agree. Yeah, and that's why I separate them, right? That's to a T the reason why I keep them separated. In my mind, yeah, handle the numbers differently than you handle the variables. Absolutely. All right. Y'all are going to be good at those. And also, if you super struggle with the fourth root of 256 and you're like, change it to 256 raised to the 1/4 power and use this tool. 256 raised to the 1/4 power. Yeah, she's a 4, right? So you have the ability to use your calculators on these things. So you should be A-okay when it comes to this. All right, solving equations. Ooh, here we go. We're going to solve this equation. We have 2x to the 5th equals 64. Now, they solved a couple of them for us. So, Riley McKellips, what did they do from step 1 to step 2 right here? Yeah, divide both sides by 2. Really good job. Really, really good job. Blaine, what did they do from step 2 to step 3? Read that box right there, Bubba.
they raise each side of the equation to the power of 1/5.
Yeah, that's exactly right. Both sides now have the 1/5 power. Really good job. And 5 raised to the 1/5. Now, the reason why they did this, right, 5 raised to the 1/5, they have power raised to a power you're going to multiply. And 5 raised to the 1/5 power, well, really, whenever I think about any number times its reciprocal, right? X times 1 over x. Well, that's x over 1, and we end up with x over x, which is just a 1. Ultimately, when you're trying to get 1x by itself, that's the idea, is to get that as your exponent. So that's why we raise each side to the equation, each side of the equation to the reciprocal power. All right, Butch, what did they do on part B from line 1 to line 2? Divide by 3. Yep, really, really, really good job. Good. Rogan, what did they do from line 2 to line 3? Yep.
line 2 to 3.
Uh-huh.
They multiply each
Easy.
side by
Raise. Use the word raise.
raise each side by 1/4
To the 1/4
power.
power. That's exactly right. So raise both sides to the 1/4 power, that reciprocal power. Now, let's see here. Blaine, can you tell me why did we get a plus minus on this problem, but we did not on this problem?
Because it's odd.
Really good job. Yeah, so here we had an odd root. So the solution is just the principal root. Right? Here we had an even root, meaning 1/4. The number 4 is even, so I'm looking for an even root, and that's why we needed both the positive and negative of the principal root. Okay, moving on. 2 more. We can do it. We do hard things all the time. Here we go. Solve the equation. 5x to the third equals 320. Summer Bradshaw, what's your first step, dog?
Stop rushing me.
I'm not from Russia, so you cannot call me Russian. Divide both sides by 5. Yeah, good job. Quit rushing me. So we're left with x cubed equals...
I don't know.
Oh, everybody knows 320 divided by 5, dog.
64.
Oh, okay.
I forgot about that.
All right. So let's take note right now. Luna, are we dealing with an even root or an odd root this time? Can you tell me if 3 is even or odd?
3 even or odd? Odd.
Oh, good. Thank you, sweetie. So we're dealing with an odd root. Very good. So we got to raise both sides of the equation to what power? The 1/3 power. Yeah, really good. So this side to the 1/3, this side to the 1/3. So that leaves us with x equals. Now, what is the cube root of 64? 4. Good job.
No, it's 5.
All right, part B. Solve this equation. 2p to the 4th equals 162. Summer Bradshaw, what's your first step?
Divide by 2.
Yeah, good job, dog. Divide both sides by 2. So we get p to the 4th equals 81. Oh, that's friendly. All right, Luna, is this an even root or an odd root problem?
It's 4 even. Oh, even?
Even, yeah, thank you. So we have an even root here. So pay attention. What happens when we have even roots? So, what do we raise both sides to the power of? 1/4. All right, so 1/4 here, 1/4 there. So P equals? Ooh, good. Plus or minus 3. Good job, Amaya. Proud of you, dog. All right, the rest of the hour is yours to do your homework.